recording and I've got audio. Excellent. Now, start this around the room. It's the 29th, correct? I do. You might want to wait until the end of class to turn it in, though. Would you please pass that around? The first thing we're going to do is address homework questions. So who has any questions about homework? I know you got one. Yeah, you can have yours back. Oh, hold on a minute there. Tony, I got a couple for you here. Chris, you want yours back? Nick, you want yours back? Oh, there you are. Sneaky little bugger. Here you go. I don't have one for you yet. Oh, no, I got stuff to give to you. Yeah, there's one. Not yet. I've still got more. And that one. Thank you. Now, which one do you have a question for, Kennedy? Number 48. A rocket rises vertically from rest with an acceleration of 3.2 meters per second squared until it runs out of fuel at an altitude of 775 meters. At this point, its acceleration is that of gravity, downward. What is the velocity when it runs out of fuel? How long does it take to reach this point, that altitude? And they told you the altitude in the question, didn't they? Did they? Don't write that down yet. That's not the right answer. Did they give you the altitude, the maximum altitude in the question? Huh? They said it runs out of fuel. Is that the maximum altitude it gets to? No, that's when it stops accelerating. What's its velocity at that point? You let go of the accelerator in your car, does it immediately grind to a screeching halt? No. No, it's still going to keep going up. So let's take this one step at a time. And we'll start by drinking some more coffee. I don't have my calculator with me, so everybody get yours out. It starts from rest. So V naught is 0 when it first launches. But its acceleration is 3.2 meters per second squared. Until it runs out of fuel at an altitude of 775 meters. Alexa. See what I got for you here. Get this. Nope, I don't have a lab for you. Just that. Thank you. Okay. From that point, it continues on to some maximum altitude. At which point it falls back to Earth. Now, what we're going to have to make, the assumption we're going to have to make is that that initial 3.2 meters per second squared is the net acceleration. That means the acceleration due to the thrust plus the acceleration due to gravity. That the combined two leaves a net plus 3.2 meters per second squared of acceleration. So, right out of the gate, we need what? Say again? We need an equation. So let's make sure we've got our kinematic equations to choose from. All right. Say again. Oh. Okay. All right. Which of these equations? Well, I wrote those small enough. Can everybody read them? Okay. Which one of these equations does it look like we're going to need? What's the first question we're asked? The velocity when it runs out of fuel. Okay, well, we know what its acceleration is. We know what its. We know the delta y in this case because vertical instead of horizontal. But so we can write v1 equals v naught up. Anybody catch it? Should be v1 squared. We've been through that. V sub naught squared plus 2a times 775 meters. And a is 3.2 meters per second squared times 775 meters. And we know V naught is 0. So what's 2 times 3.2 would be 6.4 times 775. Somebody get it yet? 4,960. Check our units. V is squared, so that should be meters squared per second squared. Here we've got meters times meters is meters squared per second squared. So our units are good. All right, what's the square root of 4960? Say it out loud. 70.4 meters per second. That is our first answer. Everybody see how we did this? Let me rephrase that. Is everyone ready for the exam y'all are going to be taking home at the end of class? It is a take-home exam because we're making up for not being here on Monday. All right. That means that y'all all need to ace this exam. Okay, B, how long does it take to reach that point? How long did it take for this rocket to get from here to 775 meters? Which equation do we need now? Say again? We know how fast it's going when it gets there. Seems like this one would be an awfully convenient one to use. We know acceleration. All we want to know is time. So we write v70, the final velocity, 70.4 meters per second, is equal to initial velocity was 0 plus 3.2 meters per second squared times time. How would you solve for the time? Divide 70.4 meters per second by 3.2 meters per second squared. Say again. 22 even. Okay, check your units now. Meters per second divided by meters per second squared is the same thing as meters per second times second squared per meters. They cancel, one of those cancels, and it leaves units of seconds. So, this is B. That's our second answer. Now we need to know what is the maximum altitude the rocket reaches. Once it runs out of fuel, what acceleration is it experiencing once it runs out of fuel? Once the thrust drops to 0. Its acceleration becomes minus 9.8 meters per second squared. And we want to know the maximum altitude it reaches. So we know at this point now, V1 is our V sub naught, the initial velocity from this point. So basically, which one of these equations will we use now? Boom. That's all we're looking for is this, right? We know everything else. We know that what will its final velocity be when it reaches the top? 0. So we write 0 squared is equal to its initial velocity, which is 70.4 squared. Fortunately, we've already got it squared. Plus 2 times minus 9.8 meters per second squared times delta x, or in this case, delta y. So 9.8 times 2 is 19.6, right? Somebody confirm that. Do not trust me to do arithmetic in my head. Say again? 2 times 9.8. I think it should be 19.6. Okay, so 0 squared is still 0. And that's equal to 4960 meters squared per second squared minus 19.6 meters per second squared times delta y meters. Add this to both sides and we get 19.6 meters per second squared times delta y meters is equal to 4960 meters squared per second squared. Checking our units, meters times meters per second squared is meters squared per second squared on both sides. And for the record, even though this was a 0, it was 0 what in terms of units? Meters squared per second squared. So our units are still good. And now we just divide both sides by 19.6. .6 meters per second squared. The per second squareds cancel and one of the meters cancel, and that leaves us with units and meters. So our units check out. Someone do the arithmetic. Say again. 253 meters is how high it goes from this point. So what is its maximum altitude? 775 meters plus 253 meters equals you're going to have to speak up over the rate. 1,028. Is that what everybody else gets? And there is our third answer, C. Now, D. How much total time does it take to get from here to here all the way up to there? We already know it takes 22 seconds to get from here to here. So how long does it take to get from here to the top, to the max altitude? Which question or which equation are we going to be using? Why not, right? We know the velocity at the top is 0 meters per second. We're going to use V equals V naught plus AT. V is 0 meters per second. And that's equal to, what's its initial velocity? 70.4 meters per second. And its acceleration is minus 9.8 meters per second squared times t. Add this to both sides and we get 9.8 meters per second squared times time is equal to 70.4 meters per second. Divide both sides by 9.8. I'm sorry, say it again. 7.19. Okay, so add that to the 22 seconds. That's our what? That's D. Anybody get something different? Y'all are really going to have to speak up for me to hear you over this roof rattling. Okay. E. How fast is it going when it hits the ground? Well, this is a really interesting one that everybody should pay attention to. Which equation are we going to use? First one, bingo. All right, how fast is it going when it hits the ground? What's its initial velocity? 0 meters per second at the top, minus 9.8 meters per second squared times time. Oops. How long does it fall for to get from the top to the bottom? We know how long it took to get up. We have no idea how long it's going to take it to get down. We know its acceleration is constant. So, we don't know what this final velocity is going to be, or if we did, we could use this equation to solve for time. But what are we trying to do right now? We're trying to find out how fast it's going when it hits the ground. And here we have one equation with two unknowns. Now, I don't know if y'all remember this from algebra, but in order to solve a system of equations, you have to have one independent equation for every unknown that you're looking to solve for. If we need two unknowns, we need two equations. So this one's not going to work for us. Which one do we use now? Second one or third one? Why would we not use the third one? No, we're not solving for time. No, we're solving for the how. What's our question? How fast? What velocity does it strike the Earth with? What? No, we're looking for how fast is it going when it hits the ground. Well, we know how far it's got to fall. We know its initial velocity from the top will be 0. And we know that the only acceleration it's experiencing is gravity. So yes, with this, in this case, the only thing we don't know is this. I'm sorry, not that, is this, what we're solving for, velocity. So, let's try this again. Now we're going to write our final velocity squared is equal to our initial velocity squared minus 2 times 9.8 is 19.6 minus 19.6 meters per second squared times, how far does it fall? Nope, 1,028. That's 1,028 meters. What's the, somebody do the math. 1,028 times 19.6. It would, but we're looking for magnitude, so in this case the sign just means it's going down instead of up. $26,000. Say again. 23,000. 600. 20,000. 148. 140.8. Okay. 148.8 meters squared per second squared, and that's equal to our velocity squared. Now, does everyone understand what I did with that negative sign? The negative sign in this case just means it was going down, so we're just ignoring it. We're looking for the magnitude of the velocity. What's the square root of this? Meters per second. Is it an even 142? 141.142 works for me. That's how fast it's going when it hits the ground. Now, what was the time, what was the duration of its total flight from the time it took off to the time it hit the ground? We know it took how long to reach the top? It took 29.19 seconds to get from the ground to the top. How long did it take to fall back down? We've got our final velocity. We've got the initial velocity from the top coming down. And we've got acceleration. All we need is the time, so let's use that one. Velocity final was 142 meters per second. That's equal to 0 meters per second, the initial velocity from the apex, minus 9.8 meters per second squared times time. Again, we're just going to ignore the negative sign because we're looking for magnitude, not direction. 142 meters per second divided by 9.8 meters per second squared equals 14.5 seconds. 14.49 you said, right? Okay, still rounds to 14.5. That was the time it took it to fall. So its total time of its total flight (29.19 seconds plus 14.5 seconds), and that's 43.7 seconds. Did somebody else get a different answer? Somebody with an actual calculator? Okay. Then you rounded differently than I did. 29.2 plus 14.5. That 22 was the time it took to get from here to here. And then later we figured out that it took additional time to reach the apex, which gave us this total time of flight in part D. The total time it took it to reach the top was that 22 seconds plus the 7.19 seconds it took to get from here to here. Or 7.2 seconds. And that's what gives us the total time from the ground to the max altitude. Where did I? Yeah, then we found the time it took to fall. And we added both of those together to get the total time of flight. So there are actually 3 periods that are being added together. There's a period to get from here to here, where it runs out of fuel. Then the next 7.12 seconds where it reaches its maximum altitude. And then the final, what was it? 14.5 seconds for it to get back to the ground. Any questions? Everybody got all this? All right. Any more homework questions before we start actually doing today's lessons? I heard someone say 37. Yes? Mary and Sally are in a foot race. When Mary is 22 meters from the finish line, she has a speed of 4.0 meters per second and is 5 meters behind Sally, who has a speed of 5 meters per second. Sally thinks, which one is Sally again? Thinks she has a easy win, and during the remaining portion of the race, decelerates at a constant rate of 0.4 meters per second squared to the finish line. What constant acceleration does Mary now need during the remaining portion of the race if she wishes to cross the finish line in a tie with Sally? Wow. Could they have made that any more convoluted? Okay. Let's keep the players straight. We've got, what's the first one? Mary is 22 meters from the finish line, the speed of 4 meters per second, and 5 meters in front of her is Sally. All right. Sally. Mary. Okay, what is Mary's velocity? .0 meters per second. What is Sally's velocity? 5.0 meters per second. Okay, Mary is 22.0 meters, is that right? To the finish line. And Sally is 5 meters closer, which means that she is, what's 22 minus 5? 17? Sally is 17 meters from the finish line. Okay, now Sally decelerates at 0.40 meters per second squared. And we want to find out Mary's requisite acceleration in order to cross the finish line at exactly the same moment as Sally. So the first thing we got to figure out is how long does it take Sally to cross the finish line? Everybody understand that's the first thing we need to know. So, which of these equations? No, we don't know. Nope, we can't. Yep, we are going to have to use the second one. So, we will call, for the purpose of this calculation, we're going to call her 17 meters. We're going to call, let's do it this way. We'll call this the 0. X equals 0. We'll call this x equals minus 17. And for velocity, we've got, so okay, we're going to solve for x equals 0 equals minus 17 meters. Her initial velocity is 5 meters per second. Times time. Plus, which, nope, that needs to be a minus because she's going to slow down. Minus 1/2 4.0 meters per second squared times time squared. Say again? Oh, that should be a 0.4. You're right. Thank you. Okay, and half of that would be 0.2, right? So we've got 0 equals minus 17 meters plus 5 meters per second times time minus 0.2 meters per second squared times time squared. And that's what we need to solve for time. So, I guess the first thing, is there a convenient way to do this? Quadratic formula is about the only way I see to do it. So let's put it in the standard form. We've got 0 equals minus 0.2 t squared plus 5t minus 17. All right, so we're looking for t equals minus 5 plus or minus the square root of 25, which is b squared, 5 squared, minus 4 times negative 0.2 times negative 17. So 0.2 times 4 times 17 is what? Say again? That really multiplies out to 13.6. So we get, that's all over what, 2 times a, so that's all over minus 0.4. Okay. $25 minus, what'd you call that? 13.6 divided by, okay, 25 minus 13.6 is, say again. All right. What's the square root of 11.4? Okay, what's minus 5 plus 3.38? Negative 1.62, you said? And what is, that was minus 5 plus 3.38. What is minus 5 minus 3.38? Okay. 1.62 divided by 0.4. And 8.38 divided by 0.4. Say again. Okay. So we've got two possible answers here. 4 seconds or 21 seconds. How do we interpret those? Say again? What? Well, this is just, there's no negative here. We got -5 plus or minus 3.38. So it's either -1.62 or -8.38. In both cases, it's divided by -0.4. So it comes out positive in both cases. We have two positive times. There, yes, you're getting the right. You're on the right track. How would you interpret this 21 second? What does that time represent? Say again. No. From this point, she is moving with a constant velocity at that moment of 5 meters per second, but she's decelerating at -0.4 meters per second squared constantly. So what happens? 4 seconds later, she crosses the finish line. If she doesn't stop at that point, if she continues to decelerate at a constant -0.4 meters per second, at some point up here she's going to stop and then start accelerating backwards, at which point she would cross the finish line a second time 21 seconds later. Okay? Remember what is the math? When you solve this equation, what are you actually solving for? That second answer means something. And this is the difference between learning the algebra, learning the arithmetic and the mathematics of how to solve a quadratic equation, and understanding what it actually means. It's the difference between English and literature. It means if she doesn't stop once she crosses the finish line, if she continues decelerating at a constant rate, she's eventually going to come to a stop and then start going backwards. So she will in fact cross that finish line twice. The first time when at the end of the race, and again because she didn't have sense enough to stop 21 seconds later. So the bottom line is, for us, this is the time that she crosses the finish line first. That's the time at the end of the race. So the next question is, what acceleration does Mary need in order to finish this race in 4.05 seconds? That's the one we have everything for. We know how far she needs to go, but we don't know what her final velocity would be, so we can't use that one. We do know her final velocity will not be the same as her initial velocity. It will be faster. And that means we can't use this one either. So yep, we've got no choice but to use the same equation. Only now, the distance that she's got to cover is -22 meters. So we want to know, she's going to x equals 0 meters, And that will be equal to minus 22 meters plus, what's our initial velocity? 4 meters per second. Times time, plus 1/2 a times time squared. But we know time, because we want her to finish at exactly the same time as Sally, so time is 4.05 seconds. So 0 equals minus 22 meters plus 4.0 meters per second times 4.05 seconds plus 1/2 the unknown acceleration times 4.05 seconds squared. What's 4.05 squared? 16.25? Hoorah, look at me. Plus 1/2 a times 16.25. What's 4 times 4.05? 16.2? And minus 22. That's not a negative, that's just a square. So, add 22 to both sides. Now subtract 16.2 from both sides. What's 22 minus 16.2? Okay, multiply 5.8 by 2. And divide that by 16.25. .71, you said? A is 0.71 meters per second squared, and we don't have time to go through and do the units, but that is the acceleration she would need to tie the race. Now, we didn't cover any of the lecture material today, so I expect everybody to get really, really high homework marks. The material we're covering, and y'all can read chapters 3.1 through 3.4 for Friday. We're going to learn about vectors. You're going to learn the difference between a vector and a scalar. You're going to want to know about projection of a vector, components of a vector. You're going to need to brush up on Pythagorean theorem, a little bit of trigonometry, and you're going to need to know the difference between polar coordinates and rectangular or Cartesian coordinates, how to add vectors, and how to subtract vectors, and how to multiply and divide vectors. And tomorrow, we're going to be doing a vector lab. So, you'll be getting some of this lecture material in labs in order for you to be able to do the lab. No, test is right here. Everybody come get one. Make sure that you've signed the sign-in sheet. Where is the sign-in sheet? Is it there? Bring these, turn them in lab tomorrow. Anybody not get one? You know, I could stay caught up with my work a lot better if I'd quit letting y'all come to class. Have a good day.